So this one is just the last one. This one is standard enthalpy change of hydration. So hydration is, and it would be written as, it's always exothermic delta H hydration. So always, so this one is also always exo. Now what happens to this is that in the enthalpy change of hydration, that you've got a gaseous ion and it turns into aqueous ions. So you've got Na plus 1 gaseous, you mix it in water and it turns into, dissolves and forms Na plus 1 in aqueous state. So it could be any ion. So it's supposed to be 1 mole of ion. And only bonds, you're not breaking any bonds. The only thing you're doing is you're forming bonds. The Na plus 1 and the water molecules are going to attract each other when they dissolve. Like there's going to be force of attraction, there's going to be bonds forming. The Na plus 1 would be attracting all the polar water molecules. So here are your water molecules, which are obviously polar. They're capable of forming hydrogen bonds. Uh, this side, the oxygen has lone pairs and it's partial negative. So the Na plus 1 would be attracting all these water molecules from all sides when it dissolves. So only bond formation happens when this happens, which is why it's always exothermic. It's going to be more exothermic if stronger bonds are formed. Or there are stronger attractive forces between the ion and the solvent, which is water in the case. So they're going to be more exothermic if stronger bonds are formed. So stronger bonds are formed if the charge is greater. Like if Na plus 1 would have a weaker attraction for water molecules, but if the charge was greater, like Al3 plus, then the attraction would be a lot stronger. So more charge, and the ion size is smaller. Smaller ions always form stronger bonds. So two factors are going to matter. The enthalpy change of hydration would be more exothermic if you can somehow make stronger bonds, and they can be formed by smaller ions because they would be closer to each other. So there's going to be more attraction, and the other one is that they would also have more charge. Is this clear to everyone?
Yep. Yes.
So, um, so I'll just write the definition now, which is that it's the proper definition, which is energy released when 1 mole of gaseous ions, 1 mole of gaseous ions are completely surrounded by water molecules. So they're completely surrounded by water molecules to form 1 mole of aqueous ions. And this would be measured under standard conditions. So, so this is standard conditions. So remember the definitions and remember what's going to happen. So just quickly going through all of them. Enthalpy change of hydration is when you just mix 1 mole of gaseous ions into water and you form 1 mole of aqueous ions. Standard enthalpy change of solution is I we didn't actually talk about this completely. Standard enthalpy change of solution is that when you mix 1 mole of any substance in water. So it could be 1 mole of any substance, whether it's ionic or covalent, and it could be endo. It could be endo or exo. Um, One thing I'm going to add over here is that when you're mixing, endo is the one that's going to be less soluble. Why would it be less soluble? Because it would require energy to dissolve. So unless you're not giving it energy, it's not going to dissolve. So this would be soluble at higher temperatures. You would have to, if the reaction is endothermic, then it would be more feasible or soluble at higher temperatures. And for exo, it's going to be the opposite. It's going to be more soluble and more soluble at lower temperatures. The other one that we did was we did standard enthalpy change of neutralization, where you have it's just an acid-base reaction, and 1 mole of water is produced, and the energy that is released is called enthalpy change of neutralization. We talked about enthalpy change of atomization, where you form 1 mole of gaseous atoms from its element in its standard state. Then we talked about combustion, which was the energy change of a reaction in which 1 mole of a substance was burned in excess oxygen. And then you had formation, in which um, you would form 1 mole of substance and you will form it from its constituent elements. So we're going to do a small worksheet now related to, let me just remove this. So we'll just do a small worksheet related to definitions. Okay, so it's this one. And just a second, why is it? So here, this one. So just quickly revising all the definitions. The first one, we'll just quickly go through this. For example, the first one is enthalpy of formation of. So I'll just quickly go through this. Enthalpy of formation of CH4. This is the enthalpy change of a reaction in which 1 mole of CH4 is going to be formed from its constituent elements, and the elements are going to be carbon and H2, and the elements must be in their standard state. So carbon would be solid, and H2 would be gas, and CH4 would also be a gas, and this should be 2 H2. Is this clear?
Yes.
So
Yes.
what's the enthalpy of formation of Al2O3? 1 mole of Al2O3 is formed from its constituent elements. It's the energy change of this reaction. So the elements are aluminium and oxygen. Oxygen is diatomic, and you have to form 1 mole, so it's going to be 2 aluminiums and 3 by 2, and it's going to be 3 by 2 oxygens. Similarly, if you have enthalpy of combustion of C4H10, now enthalpy of combustion is the reaction in which 1 mole of C4H10 would be burned in oxygen to produce carbon dioxide and H2O. And you can, since you're burning 1 mole, so it's going to be 5H2O, and this would be 5 plus 8, that's 13. So this over here would be 13 divided by 2 oxygen. Enthalpy of atomization of Al would be that 1 mole of Al atoms are going to be formed from its constituent element, and the element is the metal aluminium. So it's the energy change of this particular reaction. And for bromine, I think we did that as well. 1 mole of bromine atoms are formed, and they're formed. Okay, so they are formed from its element, which is Br2, which is a red brown liquid. So there's going to be half of these. Is this clear?
Yes,
Yes,
but
I
do
agree.
we always have to mention this, the states?
The states are important actually because, I mean, for example, I didn't mention the states over here, but the states are very important. This one would be a solid. H2O would be, since if you're doing this in standard conditions, then you have to mention the state. Butane is a gas. I said this one. Can somebody quickly tell me what would be the label that you will give to this one, the first one? What would you call it? Enthalpy of what?
Combustion.
Formation of formation, I think.
So it's going to be enthalpy of formation of H2O2. It's not going to be combustion because somebody said combustion. In combustion, I told you it's a spontaneous reaction where one mole of a substance burns in excess oxygen. When you burn H2, you never get hydrogen peroxide. That's never formed. It's always H2O that's formed. So this is not a combustion reaction. As a similarly, what would you call this reaction? The energy change of this reaction, it would be called what? Enthalpy of what? Anyone?
Formation.
Formation.
It is formation because a substance is being formed from its elements. So it's enthalpy of formation of NaCl, but there's one thing wrong with this. What is that?
It's not 1 mole.
It's not 1 mole, so it's basically twice the enthalpy of formation of NaCl. The value is double the enthalpy of formation of NaCl. So what is number three? What is number three called? I mean, the energy change associated with this reaction is.
Hydration.
No, this is not hydration. This is solution. It's the enthalpy of solution of FeSO4. Okay. Now there's a very minor difference between solution and hydration. In solution, an entire compound is dissolved. In hydration, you're just mixing one gaseous ion in water. This one is hydration. Is this clear?
Yes,
Yes.
sir.
And the last one is obviously the standard enthalpy change of combustion of C8H16. So now, next question. So you'll be asked definitions, and he's saying including state symbols. So remember, state symbols are important. So alcohols, he's saying defined with the native of an equation, the enthalpy change of combustion of methanol. So it's basically CH3OH, which is a liquid, and reacts with oxygen, and it would produce carbon dioxide and water. That's it. And there's going to be one carbon dioxide and two water molecules, and there's going to be two O2 molecules. This is gas. This is also, and H2O is a liquid. And you can write the definition that it's the energy. It's always released. I mean, we've already written the definition. Released when 1 mole of a substance. Now, since we are very specific, 1 mole of, let's talk about methanol, burns in excess oxygen, measured under standard conditions. As the next one is again define the term standard enthalpy change of combustion. So you can do that. Uh, it's the same one. Explain what is meant by the term standard. What does standard mean? Anyone? You talk about standard enthalpy change. So what is standard? Like what does it represent? Anyone? What?
That means the
No, your voice is breaking up. It means the
it means
temperature.
the reaction takes place under
Yes, France. Under standard
it means
conditions.
it means the reaction is taking place under um, 1 atmospheric pressure.
Okay. And it's 298 kelvins or 25 degrees centigrade. Or the third one is that if it's a solution, then the solution is going to be 1 mole per decimeter cube. So you can write statements like the temperature should be 298 kelvins The pressure should be 1 atmosphere, and the concentration of the solution, if there is any, should be 1 mole per dm3. Over here, he's talking about writing the enthalpy of formation of water. So that's the elements reacting to form H2O, and again state symbols. So this is gas and this is a liquid. Now I explained this. He's saying, why does the enthalpy of formation is identical to the enthalpy change of combustion of hydrogen? What is the answer to that? He's saying that enthalpy of formation of H2O is the same as the enthalpy change of combustion of H2. Why are they same?
Because
Because
burning hydrogen and oxygen gives you water.
So it's basically the same reaction. I mean, both of them represent the same reaction. So they both represent the same energy change. So they're obviously the same value. I mean, you're giving them different labels, but they are exactly the same. So enthalpy of formation of water is you make 1 mole of water from its elements. Enthalpy of combustion of hydrogen is you burn 1 mole of H2 with oxygen to form water. So it's basically the same. They both, so that's the thing that you're going to write. You both represent the same reaction, which is this one. Hence, they have the same value. So anyways, let's do some. I mean, this one looks slightly tougher. You have to. He's saying what is X. Basically, he's asking what is X. So what's happening over here? There's a water molecule being formed from what? From its elements. So what would you call X?
Formation of water.
Okay, so it's going to be the enthalpy change of formation of water, but how many moles?
2 times.
Okay, so it's going to be twice the enthalpy of formation of water. So that's one way to identify that. So it's basically D, right? You're forming 2 moles of water. Or another way to represent this is you could have also called it. I mean, what's happening to H2 over here? It's burning with oxygen to produce water, right? So you could have called it the enthalpy change of combustion of H2 as well, because you burn H2 and you get H2O. But since you're burning 2 moles of it, so it's going to be twice the enthalpy of combustion of H2. So they gave us both. They gave us enthalpy of combustion of hydrogen or enthalpy of formation of water. But enthalpy of combustion of hydrogen is also times 2. So that is not given. So you can't define it that way. Is this clear?
Yes.
Yes.
So next one is, which energy change corresponds to the enthalpy change of atomization of hydrogen? So what is atomization of hydrogen? 1 mole of hydrogen has to be atomized from its constituent element, which is H2, which is gaseous. The element must be in its standard state. So the energy change, and remember I told you about atomization when we were doing this. Once again. So I told you about atomization, that sometimes when you are talking about atomization, you can actually find the value in the data booklet. Where is atomization? This one. So I told you that in atomization, you're breaking the element into atoms, right? Uh, so carbon solid turning into carbon gaseous atom, oxygen molecules turning into oxygen gaseous atom, bromine, which is in liquid state at room temperature, turning into gaseous bromine atoms. But I told you that sometimes you can use bond energy data to actually figure out, because bond energy data that's given in the data booklet is calculated for gaseous substances. So if oxygen is turning into oxygen gaseous atoms, so the thing that you're doing is you're just breaking the oxygen bonds, half of them, because you're breaking half a molecule. So uh, you'll get the value of atomization from the data booklet. But a lot of times when the states are not gaseous, uh, because energies are defined for gaseous substances. So if they're not gaseous, you can't use bond energy data. It can't be used. So over here in this question, you can obviously use bond energy data. So what are you doing? How many bonds are you breaking in this reaction? It's
Half.
okay, you're just breaking half a molecule. So basically, you're breaking just half of a bond of H2, right? So it's going to be, and you're breaking it, so it's going to be positive. So it's half the bond energy of HH bond. Like if you break one bond, you get two H atoms, but since you're getting just one H atom, that's half of that. So then you have this question. What did we talk about enthalpy change of, this is an acid-base reaction, it produces water. So what did we talk about enthalpy change of neutralization? I told you that it always has the same value. Why? Because it's always the same reaction. The acid, whether it's HCl or HNO3 or H2SO4 or whatever, the main purpose of the acid is to produce just H plus one ions, and the base produces OH ions. So you always have the same reaction, which is why the value is always the same. And 1 mole of water must be formed. So in this case, there are 2 moles of water that are forming, so the value is double that. So it's minus 114. So he's asking what would be, so this is the enthalpy change of the first reaction. So he's asking what would be the enthalpy change of this second reaction. And what is it going to be?
A.
It's going to be C.
It's C. Okay.
2 moles of water are being produced. Okay, be careful. I mean, minus 57 is for 1 mole of water. Is that clear?
Okay.
Yes.
So it's going to be minus 100. I mean, they're both going to be exactly identical.
Sir,
Yes.
if it was under standard temperature, then would it be minus 57?
Not standard temperature. If this was 1 mole of water, because the definition is that it's the energy released when 1 mole of water is formed. So if it's 1 mole of water, then the enthalpy change would be exactly minus 57. If you're making 2 moles of water, like this over here, then the enthalpy change would be double the value because you're making double the quantity. Is that clear?
Yes, sir.
So, so the only reason it's minus 114 is because you're making twice the amount of water. As anyways, you're supposed to predict the sign. What is atomization, endothermic or exothermic?
Endothermic.
Endo.
Okay, so it's always endo because you're going to break bonds to form atoms. And what about formation and solution? Is it going to be endo or exo or both?
Formation is endo.
Sorry, this one. So formation can be both actually. With formation, it can be plus, it can be minus, because I told you that when you're forming a substance from its elements, both things are happening. You would have to break bonds from the elements, like the HH bond has to be broken, the OO bond has to be broken, and then you're going to form new bonds to form the substance. So in enthalpy of formation, if both things are happening, bond breaking and bond formation both are going on, so it would depend. Sometimes it would come out to be endo, sometimes it's going to come out to be exo. If the bonds are really strong in the elements, then it would come out to be endo. If they're weak, then it would come out to be exo. And the same was true for solution. I told you that solutions can be both as well. So it's going to be B. Dissolving a substance also varies. Sometimes it's endo, sometimes it requires energy, sometimes energy is given off. As the next one, which one of them is the enthalpy change of atomization of iodine?
C.
Okay, it is C. You're going to make 1 mole of gaseous atoms from its element. And the element is I2 and it's solid. It's blue-black crystals. So this is C. So this one again. Now, in enthalpy change of neutralization, we did, where is neutralization again? Now I said that if you make 1 mole of water, and an acid base react, the value is minus 57. But I also said that the value is going to be less exothermic, or it's going to be less than minus 57 kilojoules per mole for weak acids and weak bases. And I also told you that what are weak acids? They're organic acids. What are weak bases? The one that contain nitrogen atoms. They are your weak bases. Uh, so it's going to be less than minus 57. So you can see over here that in the question, the first one is minus 57. So that's a strong acid, strong base. The second one is less than minus 57. So that means it's either a weak acid or a weak base. And the third one is also less than minus 57. So that's also either a weak acid or a weak base. And the last one is again minus 57. So that's a strong acid, strong base. Is this clear? This thing.
Yep.
Yes.
I said now, so what would P be? That's going to be a weak acid. Because you're getting minus, so it's either sulfuric acid or ethanoic acid. So it's going to be P is going to be ethanoic acid. It's going to be a weak acid.
Wait, so
Yes.
what determines whether it? How does the enthalpy change determine whether it's weak or not weak?
Nee, how does the enthalpy change determine? What's your question?
How does the enthalpy change determine whether it's a weak acid or not?
Nee, I told you that for a strong acid, the value is always minus 57 or close to minus 57, right? And if the value is less than minus 57, if it's less exothermic, like if it's not minus 57, it's less than minus 57, then that indicates that it's a weak acid. And I told you the reason as well, that some energy, because a weak acid doesn't really ionize, it doesn't produce H plus ions that easily. So some energy gets used up in ionizing the weak acid or base. So the reaction becomes less exothermic. Is that clear?
Yep.
Yes, sir.
So, I mean, these two were minus 57. So that's a strong acid, strong base reaction. This was minus 54 and this was minus 52. So that indicates it's a weak acid, weak base reaction. Similarly, now you have Q. Q is going to be a weak base because it's minus 52. So Q is, you've got two options, ammonia or sodium hydroxide. So it's going to be ammonia. And the last one, again, is minus 57. So that's a strong acid, strong base. So you need a strong base over here. So that's potassium hydroxide. So hence, the answer is going to be A. Is this clear?
Yes, but
Yep.
teacher, can the enthalpy change, can it exceed negative 57?
Normally it won't. I mean, it's minus 57 is not a very fixed value. But anything close to minus 57 or minus 57, that's a strong acid. It wouldn't exceed minus 57. I mean, it's not
Okay.
it's not going to exceed minus 57. I mean, it will exceed minus 57 if you're making 2 moles of water. Then it's going to be double the value. I said, so this one, you have this reaction over here. What would you call this reaction? Is it formation or combustion or both?
Formation.
Both.
It is both. I mean, it's either C or D, because you can call it the formation of water because it's forming from its elements, or you can call it the combustion of hydrogen because hydrogen is burning in oxygen to produce H2O. So you can call it both. What would be the energy change? Is it going to be exo or endo?
Exo.
So
Okay. So it's going to be negative. It's going to be exo because if you can call it the combustion reaction, then obviously all combustion reactions are. I mean, combustion is always exo. It's always negative. Formation can be plus as well as minus. But since you can call it a combustion reaction, it is a combustion reaction, obviously. So it's always going to be exothermic. Combustion reactions are always exothermic. So I think this is the last question. It's the formation of propane. Propane is a gas. It's C3H8. and it would be formed from its elements. The elements are, I think it's going to be, which one is the correct equation? I mean, this is wrong because propane at room temperature is not a liquid.
C.
C.
Okay, so it's going to be C, that carbon is going to be a solid and H2 is going to be a gas. Elements forming the compound. So okay, let's continue tomorrow then with Hess law. Okay, we're going to start Hess law tomorrow. We're done with definitions. Just make sure that you have all the definitions are on your fingertips and you remember all of them. Okay. Okay, then take care.
Okay, thank you. Yeah.
Love is.
Bye, sir.
Bye.
Okay, sir.